for joining us. So, yeah, this is what we're here to talk about. The title has a bit of a clue about this, and this isn't about running iOS or Windows. This device that we've got in front of us is running an open glibc Linux system stack. This is Jolla's first one. Okay. Talk a little bit about who we are. I'm Dave Greaves. I've been around a while. I used to work at British Telecom. I used to work in the kind of open source stuff around Nokia with MIMO. Eventually that merged with Nokia's plans and became MeeGo, which didn't actually end too well. So a couple of us in the open source kind of area looked at the MeeGo project, picked it up, trimmed it down an awful lot, and created an infrastructure and system called Mer. And we have a lot to thank for Nokia and Intel for being very open in what they did, because they allowed us to essentially do that. Martin?
Hi, good morning. I'm Martin Brook, V-Grade on Twitter and other social media. My day job is working for Pelagico, and I'm currently based working with Jaguar on their build systems. And I'm part of the SailfishOS community.
Okay, cool. So, and this isn't a Jolla pitch. I'm here as an open source person. I work for Jolla. But you know, I am really proud of what we've got here. This is a device that has a really beautiful UI. And if you haven't seen it, come and have a look. We're demoing the device and showing off how it works. And I'm actually personally proud that we've proven the Mer operating system. And 90 people put this device together in less than a year, and that's some real credibility. You know, it was the original target for SailfishOS, the first Mer product on the market. But we have this program now called Sailfish for Everyone, and what that's doing is it's letting us run Sailfish on these devices as well. So we've got the Nexus 5, Nexus 4, Galaxy S3, and a few others. We've got a kind of a status report that we'll have a look at later. And what we're doing on there is we're using some technology that we've developed, and we've been working on documenting this. This little tome, I didn't realize how bloody big it was until we printed it out. But actually, when you kind of get it on your desktop, a lot of this is just cut and paste stuff. And the point is it explains and teaches. And that's very much about what we're trying to do. We're trying to help people learn how to do this, not just press a button and kind of have it come out the other end. That's not what it's about. It is all about hacking. And, you know, it goes through, this is kind of like a table of contents, the bits that you do. You prep your device, you go through, you do some packaging, flashing, tweaks, patches, building devices. So my kind of take on open source stuff is that you've not really done open source work until somebody else has replicated your work. You know, if it's not shared and somebody else can't replicate it, you're not finished yet. Okay. And this is all working on, you know, the point of this is it's working on Android-based devices. So Android BSPs for those who kind of use that level of terminology. But let's have a little bit of a talk about the kind of the technology we use, you know, that runs on devices. As I mentioned, we wanted this kind of really beautiful UI, and that was important to us. So Qt is an important technology choice. And we didn't think there'd be many Java people around this conference, so looking at QML as an alternative to Java was one of the things that we were looking at when we were doing the technology selection. It's really pretty performant, it's very open, and it's very open in a contributory sense. You know, we control, the community controls the development of Qt. So it's not something which is controlled by a specific single organization. So you look at things like Java and the way that Android is developed, and that's quite different. And there is a huge developer base. Qt's been around for a long time. It's very heavily deployed into kind of commercial organizations because it already runs on multiple platforms. And the single most important aspect for us is the QML aspect, which separates the user interface from the functionality of your application. Move on. One, not two. And yeah, we can talk a little bit about how we've got Qt Wayland replacing the Surface Flinger layer. And you can see that this is something that you're probably familiar with in terms of an architecture if you're familiar with the Android graphical systems. But we do still have stuff that's going on at the bottom, and we are still using some of these technologies. So I'll talk a little bit about how we do that later on. We'll also talk about the fact that we've got an SDK for the device. I'm not going to talk about the apps SDK here today, but what we've essentially done is put together the Qt Creator IDE together with a build capability that runs now on Macs, it runs on Windows, and it runs on all flavors of Linux in a very straightforward manner. And I suspect a lot of you here will actually use Linux. I mean, how many people have Linux desktops and use Linux? Is that, yeah. So these technologies are things that you are familiar with, and this is what's running on the device. Yeah, some of them though will kind of bring up a few opinions about whether they should be there, but you know, this is a technology choice, and it's something that we thought suited the device. So yeah, one of the other really key parts of this is Hybris. Hybris is something which is an interface between the Android technology and the libc technology. Nowadays, when hardware vendors come to the market, what they do first of all is they create an Android base support platform, and that's great. But it also includes user space blobs that support the GPU, the modem, haptics, sensors, cameras, GPS, and they're all put there in the Android space, and they're all linked against Bionic. And that really is a bit of a problem if you're not using Bionic, which is the core C library in Android, and you're using glibc. So to summarize, we've basically put together a linker level interface between Bionic and glibc. For those of you who care, in the linker, we do things like we kind of do dynamic library opens, we look for symbols, and we've renamed them and rebuilt the linker and put that into the actual shared object for Hybris, which now means that we can run glib and Bionic in the same address space. And it turns out that it kind of does work. It sounds like it's going to have all kind of gotchas, but there's not that many. We have to take care of things like threads and thread storage. There's little numbers, like when you get an error, a system error number variance between the two libraries need to be managed. There's some issues around the APIs, and things like the dev log stuff where Android writes its system logs need to be handled. But basically, we put all that together, and it means that you can write a relatively small bit of code that opens some GL library and then finds the symbol and then passes it back, and we do that for each of the symbols that are exposed in the library, and all of a sudden you've got access to 3D graphics acceleration. Some of them are more complex, and some of them have some interesting tricks. So if it's something that kind of makes you think, oh, that's cool, come and have a look. It's all open source. And these are the areas really where that thing is required. If you want to access any of these low-level drivers, you need to have that level of access to them, that in order that you can then integrate them into something like Qt, and then from Qt you get a really nice kind of open camera level interface which you can then start using in your apps. Just noting off. Yeah, so I was just commenting on that. We've got most of this all works for CyanogenMod 10 and CyanogenMod 11, which is what we use as the base for doing this build, on the grounds that, well, it's already been ported to a lot of devices, and things like the routing and such like. We could just have gone and reinvented this and redocumented it ourselves, but it makes a lot more sense to share with other communities that have already gone out and done this work. And that's one of the reasons we're here at XDA, is because there's a community that's out there hacking mobile devices, they're getting root, they're building kernels, they're documenting the ways that you get into the bootloader. It wouldn't make sense to go and set up our own little labs website and that kind of stuff. What we want to do is come and say, well, you guys actually, where this is all happening at the moment, we'll come and work with you and we'll kind of contribute to what you're doing. It seems a more constructive open source approach. So how do you actually go about building this? We need the haddock, which is, we've got all the nautical terms going on. We've got the sea references and the sailing references, and some smart ass decided that the hardware adaptation development kit was going to be a haddock. So we now have this fishy thing going around as well. It's very straightforward. We kind of said we've got the SDK, And that works pretty much the same on any Linux environment. We put together the cross-compile toolkit we need because we're all running on x86 desktops. We need to compile ARM stuff, so there's cross-compile stuff to build ARM binaries. And that's what the Scratchbox 2 stuff is. And we put that in with a device-specific target. So we say, build ARM for a Nexus, or build ARM for whatever the code name of the device you want is. And then we have a minimal Ubuntu development environment because the reference environment for building Android stuff is various forms of Ubuntu. So we take a minimal set of that, and our Ubuntu stuff, our Android stuff is built in there. Okay. And it's kind of nested, so that what you've got is you've got your host OS around the outside, and then inside that you've got your Mer SDK. And when you read the documentation, it's kind of important to get this picture in your head of how these things nest together and how it kind of works. The Mer SDK gives us all a standard environment. So when somebody comes onto IRC and says, hey, I'm having a problem with this command here, we don't have to say, well, are you running Ubuntu, or are you running Fedora, or SUSE, or Debian, or oh, I'm on Windows, or any of this stuff. We provide this to give us standardization, and we just make sure that everyone's running the same version of the same tools. And it's, given the storage nowadays and what have you, it's a pretty cheap solution to be very, very effective at being able to support people. And then, as I say, inside there we have the space, the nested space, where we build the Android area, the kernel, Bionic, and that kind of stuff. Essentially, that's where you're going to go and put your CyanogenMod stuff and do your Android make. Once you've done that, we kind of need to link, as I say, that the Android stuff provides information about the graphics, it provides information about, say, the phone, the Wi-Fi system, and we need to link that down from various places in the Mer and Sailfish space. And that's what's happening in here. We have to build the kind of link up into Qt, the link into Ophono, the link into Conman, and that kind of thing. Pulse Audio. So the Mer SDK, as I say, just contains a minimal install of Mer, some tools, and is Scratchbox ready. To install the HA build stuff, we just pre-prepared a big tarball. You download the tarball, you put it in, the same consistency. You may already be running Ubuntu, in which case you'll have 2 copies, which is even better. So you grab that, you install this little repo command, which is what's used to manage the source code around the kind of Android space. And then what we do is we kind of give you this specific list, if you like. It's a manifest, all the contents of the repos that you're going to need to build. And that will pull in things like, as I say, Bionic, etc., the right kernel for your device, and it's device specific. You run sync, and that, depending on the speed of your broadband, pulls down the Git repos in a short while, or if you're like me, it's like 2 days or something. And it's a mix of the CyanogenMod repos and some that we've forked and patched slightly, as I said, in order to make things like the hybrid stuff work. You run make, and then you fix any problems. Typically, for devices that are supported, there aren't any. If you're bringing up a new device, then figuring out what to put into there is part of what you need to do. Then maybe tweak the make files and such like so that they build the right things. So having built all that, you've now got a kernel, you've got the init code, the Bionic, some configs, and various bits of library that we're going to need. And as I say, we're not Android. We are a different operating system, and we use things like, we use RPM, which is something you'll be familiar if you use things like Red Hat, Fedora, SUSE. So what we need to do is take all that code and package it into RPMs, because that will then make it quite easy to manage updates and image creation for the devices. So that's what we do in the Mer area, and all it does is basically say, okay, well, from that big build space, I'm going to pick that, and that, put it into that RPM, put that, and that, put it into that RPM, that RPM. And it's just basically a big list of saying, pick from there, put into that package over there. Relatively straightforward, bit overwhelming when you first look at this sodding great big list, and this great big list of packages and all the bits of fiddling around to kind of restructure it and such that goes on. But relatively speaking, not that complicated. So now we've done that, we've got a load of packages. What can we do with them? Well, you've built a kernel, you've built some Bionic stuff, these are things we need to develop against as well. So having built these packages, I said we've got this cross-compile thing. These are ARM packages, ARM development headers. So we stick these ARM development headers and things back into the target that we were talking about earlier, so that now we can use them. Yeah? And that's the point. This is the point of making this target at this point, is to say, okay, they've got the specific headers for the device that we want to kind of work with. And because Hybris is not part of that, at this point we're also ready to start building Hybris itself, and that's where the drivers and actually such like start to get compiled. So we can now build, using that target, Hybris, the cute hardware composer stuff for doing all the fancy kind of transparencies on the overlays on the home screen, the audios, the haptics, the sensors. I haven't put camera there because we haven't actually managed to get a camera working on these things at the minute. It's a tricky thing because the vendors tend to be quite inventive in how they expose the APIs for the cameras, because they want to differentiate themselves, i.e. make it bloody difficult to hack on them. So, I'm rushing through this, but at this point you've now gone out, you've built your kernel, you've built your Bionic, you've packaged all the headers up, you've packaged the kernel up, you've thrown it back into the target, and you've built your libraries. So we're pretty much at the point where we've got a hardware adaptation layer, because that's what a hardware adaptation layer is. It's just the open source stuff at the bottom, and now what we need to do is put a SailfishOS root file system on top of it. In other words, you basically get pretty much the exact same file system that we put onto a Jolla device, and you put it onto one of those devices. I say pretty much. I think it really is just exactly the same file system. So we put that on. There's some configs and such like which are slightly different, and that's about it. And that's what we do. That's what Jolla's kind of promoting this. It's a really good thing for us as a company, but you can put your own thing on there as well. And I fully plan, I'm going to do this with tablets instead of these things. And my plan is that my mini file system for one of these things is going to go on a big tablet, which my wife is going to let me put in the fridge, and it's going to be a touch thing with just a dedicated app that allows us to do things like, manage shopping lists and stuff, because frankly it's quite useful. But that's quite cool, because it starts meaning I can now start playing with these things in a Linux space, and I can start running Linux applications on there. I'm probably going to talk about that later. Anyway, next step, get it onto the device, and nothing special. You've probably done this a hell of a lot more than I have, in terms of just using ADB and the stuff to flash onto a device. And then it will just boot. And if it doesn't, that's where we also get into the kind of, oh, right, now what? It's quite nice if things like your graphics come up, but if they don't, it's really nice if your Wi-Fi comes up, and if that doesn't, you could then have to start looking around at other ways to get onto the device to start debugging and figuring out what's going on. So it helps to know what's going on when you kind of boot. And essentially it goes through this process. The first thing that happens is the bootloader comes on. The bootloader picks which kernel to run. The kernel typically is something that we use pretty much as stock with one or two mods to make systemd work, for example, and to turn off Android paranoid networking, which we don't support. And the kernel then points at an init, which is like a really tiny shell script in the grand scheme of things. And what it does is it then starts looking for file systems and passes control over to the file system. And what we did was we did this nice little trick inside that level of stuff that writes information out. When you plug a USB device into your Linux box and look at LSUSB, you get information about it. You get the serial number, you get information about the vendor and all that kind of stuff. Well, it turns out that on a USB gadget, a device, if you go into here in the kernel and write into certain places, you can change the USB serial number and you can change the USB labels and such. So we write our debug status information into the USB messages in the init, so that you can kind of say, oh look, it's come up and it's gotten this far through the boot system. And that's quite a nice little bit of debugging if you get into hacking that. If that works, it then passes stuff onto the file system, and the file system runs systemd, and then after that it starts to run Android init as a service. And once that's up, it's a Linux distro, so you can run anything. You can SSH in, you can port all kinds of software. Node.js is the one I was kind of talking about for my Spark and Internet of Things experiments. I'm running that on these kinds of devices. Web servers, everything that you can think of that you can run in a Linux environment, Linux data centers, you can run on your device. Anyway, I shall hand over to Martin, and he can tell us a little bit about where we are.
Okay, well, I just want to talk a little bit about the community that I'm part of. We've currently got about 25 active developers working on porting SailfishOS to existing Android devices. We're working on these 22 devices listed here. So we've got really with new things, 1+1. We've got really old things like Nexus 1s. So it's a big range of devices. I'll show you the status of all those ports in a minute. The most mature images are the N4, which initially Jolla engineers worked on, but the N5 and the Galaxy Nexus are images that the community worked on. We used the hardware, the Haddock documentation to follow the steps that we needed. And as I say, they're the most mature. And I just checked this morning, and we've had 4,700 downloads of the Nexus 5 image. So it's out there and being used. So where are we on the status? So this started off as a really small table on the wiki, but it's just grown and grown. But we have. Nokia's here has got some ideas of how we present the information, the status of the port. So you can see along the top we've got the various levels of the functional areas, display, touch, and then the colour green if it's.
My Mer Project one's coming up. Actually it'll fade away.
Okay. So green means it's working. Yellow means that we've managed to talk to a little bit of hardware using the Android HAL, but it's not then linked into the Sailfish frameworks above. And then obviously red is not working, and question mark is no one's bothered to put it's not working. So as you can see, the Galaxy Nexus Mako is it's quite a lot of things working. The camera, the vertical is we need to do a lot more work on the camera. But my Nexus 5, it's if you don't need the camera, it's a daily driver for me. So that's where we are. Status wise, I'll give you there's some links later to all this information. So working together, and this is about community. This is just a couple of points in what we've done actually to bridge from where we are in our community to the the Android communities. We got a lot of requests. Can we? I don't want to put Sailfish on my device. Does it support multi-ROM? So we got in touch with Tassadar, and we worked with him, and now we've got support for multi-ROM. So that's on the devices that obviously support multi-ROM. So we worked, and a really good guy. And then the other point I've got on working together is that while doing the port to the N5, we found a bug, and we contributed that back to CyanogenMod, and they accepted, because even though the bug didn't manifest itself with an Android user space, it did with our user space, and it was a bug. So we contributed back. So we've actually got some of our contributor stuff back upstream, which is one of the big things that I'm concerned about. So communication channels. We have a Sailfish section on xda-dev. and for the individual devices, they all have their own SailfishOS thread. So they, you know, we don't get thousands of hits or readers, but you know, it's you know, we're just starting off. IRC chat is where most of the communication goes on day to day. All the source is on GitHub. You can, you know, have a look. We also have meetups. We've had meetups in London, Berlin and Finland, and I think Seabase in Berlin, first Monday of every month, and there's a get together. And we also have, well, sometimes it's probably about bi-weekly IRC meetings where developers drive the agenda, and we can talk to, you know, some guys at Jolla, just to, you know, we've got these problems, and that's working really well.
Yeah, and actually, you know, carrying on from the kind of where the work's done, our open source work at Jolla, especially in the hardware areas, is all done on Freenode IRC. So we basically live in places like SailfishOS, Mer channels and such like, and our working day is spent typically on Freenode. So that's kind of important to what we do. You know, and fundamentally this comes back to the kind of Mer thing. Our project, the Mer Project vision was to make it easy to make devices, and you know, the thing about that is that the Mer Project, the customers for it are not end users, they're kind of vendors. And things like SailfishOS and Nemo Mobile, which is a project that grew alongside Mer and has become, it's probably become smaller now, but mainly because all the Nemo Mobile code has kind of gone into Sailfish, and it's still being developed in the Nemo Mobile project, but the Sailfish stuff is pretty open. We do need a really open layer on top of Nemo that's more GPL-like probably. Yeah, and there are lots of other things around this whole area that I can talk about. I do a code is not enough kind of aspect to this, because it's great to put code out there, but there's a lot more that you need to do. There are build systems, there are QA systems, there's all kinds of other you know, best the experience, that the best practice type stuff that you need to be able to do to build a device is important. Don't have time for that today. But really, it's just a call to say, you know, come and have a go at this. It's very easy to get involved in actually hacking on the devices and doing port of a you know, a real Linux stack to these mobile devices is an incredible opportunity. Come and help us with a camera, or, you know, come and do some work on new UI. So these are the other kinds of places that we can generally find us. So, you know, please do come along. And yes, apparently I've been given a couple of things to give away. So we have questions. If there are any questions that you have, ask away.
How many devices you going to support instead of Jolla?
So the key word in there is support. This is a community effort. So if you come along and kind of volunteer to maintain a device, and for as long as you maintain that device, then that device will be part of the community effort. Yeah. So this is not something that Jolla is saying, okay, hey guys, we're supporting all these other devices and doing that. We are pushing and supporting the community as it develops these devices. Yeah. So there's no limit to it. There's no minimum. There's no maximum. And it's not something that we're going to really numerically manage. Yeah. But here, have a.
When I inevitably brick my Nexus 7 when I call Sailfish onto it later, which I probably will do,
Yep.
because, you know, we all do it, it's
Yep.
going to happen, you know, I'm probably going to miss something. How good is the community then? Because obviously, XDA community is worldwide, you can see that here.
Yeah.
So with this, is it a similar sort of thing?
Yes.
Yeah.
I'm going to say yes.
We don't have the 6 million, but,
Yeah.
but we have a a small group of engineers who you can talk to, you can get hold of us, and we'll help you out. I'll help you out.
Yeah, me too. I mean, we're on IRC pretty much.
Yeah.
It's almost 24/7. It feels
but hardware adaptation is hard, and there's no guarantees that.
Oh yeah,
You
fully aware, at my own risk and stuff.
Yeah. But yes, we'll be there. Just ping us on IRC.
And it's a good point actually, because I didn't mention that typically the first step in all of this is get CyanogenMod onto your device. I don't think I was explicit enough about that. And the point of that is that the documentation out there for CyanogenMod stuff is very, very good. It tells you button presses on the devices. It gives you risk kind of information. So what I would say is that you have pretty much the same level of risk as you have for CyanogenMod. Is it fair to say you've got slightly more? Well, we're going to ask you probably to compile your own kernel and to come in and do this stuff. And we may be asking you to experiment about putting different kernel options in. It's unlikely you're going to do anything silly like say, oh, I'll just overclock it whilst I'm at it and burn out your CPU. But you might feel like it. Exactly. Good.
On an initial device bring up, it's fast boot. It's not fast boot flash. So
yeah, that's the other thing. Usually pretty safe.
You're not doing it. You're not going flashing things to the.
Would you like a one of these? If so, come up and get one.
I would love one of those.
One of these?
I have one of them.
You've got one of these, haven't you?
I've got a hat. I got a hat yesterday. Can I have a thank you, guys.
Thank XDA.
Thank you, XDA.
Any more questions? Good questions.
For those who aren't experienced programmers,
Yeah.
there are ways to contribute in terms of wiki or documentation.
Yes.
Or things like that.
Yes. Nokius has started working on the wiki, and he's seen a need there and said, right, okay, I've gone out and I've looked at things on templating to try and put some information in there, and we're going to work on that. If you want to come in and look at documentation, the Haddock and stuff, it's a big tome. It's nice to have help on it. Testing, feedback, generally supporting, coming along and trying things out on different devices, that kind of stuff. Yeah, we're very keen on supporting that. If your goal is to become more involved, then asking the questions will help you find out ways of doing the research. So yeah, absolutely, and come and have a device, because supporting people who want to get involved is really important. But this comes with a price. You now have to come and actually talk to us.
I will.
And try it somehow, and come do some contributions.
I will, definitely.
Non-technical ones to start with. Oh yeah, and have a hat. Any more questions? Yes.
Yeah, more maybe a less technical question. Could you highlight the key features of the OS, and maybe why will we switch from CyanogenMod to that one?
Okay. Okay, key features of the OS. It kind of depends what hat you're wearing when you ask that question. If I was going to talk to somebody who wanted to make a device, I would give them one answer. If I was talking to somebody who wanted to try a different ROM on a device they own because they've tried lots of ROMs before, I would give other answers. If I was talking to a developer who was coming from the Linux world, I'd give another answer. So there are reasons that are personal as to why you would want to make the choice.
Okay, so say for the user experience for someone that uses Linux, and maybe someone who cares a bit about security.
Okay. Need more water. One of the big things about it is that the UI is a very gesture-oriented UI. So we've got lots of gesture-type stuff that goes on with it. This is kind of important to us because the point of this is things like when we're using an application and we've got things like messaging on the screen, there's no wasted space at the top. We've got little features like peek, which are really elegant ways of just taking a quick look at what's going on. immediate access to contacts and that kind of stuff. Lovely little gestures, like, you know, if you're kind of in here and you want to put the phone to sleep, just kind of goes to sleep. We have a particular fan of that gesture over there. You know? And if you have a Jolla itself, you
Double tap.
the double tap to wake up. There's a lot of user experience stuff in there that we've thought about. If you remember our heritage, we've come out of things like the N9 and the Nokia space. So, believe it or not, when the N9 designers got the chance to design a new phone, they designed the N9 because they love it, and they thought about that UI. Nokia was perhaps more conservative than we are, so we kind of just let them go a bit more to town, and they've come up with a really beautiful UI. It's not the same, and people are looking for differences, but it's functional enough. You know, these things are, you know, as Martin says, these are daily devices. So you can now try this out. You've got multi-RAM, you can switch. We can't do that we can't do everything. We haven't got full contact integration when you switch between one RAM and the other. That's kind of challenging. These Jolla devices will run Android apps. We can't do that on the devices that we're porting to. Can't talk too much about security. We're not focused on security. We have a Unix system, so we've got a lot of the Unix level security in there, but you're also talking about data protection and such, which we don't do a lot on at the moment, being honest. But on Linux side, you've just got full access to the device. You can put your apps on it and build Unix stuff on it. And I'm kind of feeling that it's getting time for lunch.
Thank you very much.
Okay.